time. Okay, ladies and gentlemen, please join me in a warm welcome for our first candidates of the Imagine 2013 competition. Here are Steve Spinazzola and Dan Andreson. Okay, so when you're watching their presentation, please keep our judging criteria in mind. The abilities for ideas to be implemented, creativity, innovativeness, relevance to society and sustainability, and of course the link to our mission, vision, business lines, and our work. Steve and Dan already introduced themselves on Yammer, so without further ado, please listen to their presentation about chiller-assisted cooling.
Good evening, fellow Arcadians. I'm Steve Spinazzola.
And I'm Dan Andreson.
And we're here to talk about our invention, chiller-assisted cooling, or what we call CAC. Everybody in this room uses data centers hundreds of times a day. Anytime you use your email, eBay, whatever, you're using a data center. Data center construction for 2013 is projected at $220 billion, with potential revenue of $20 billion globally. CAC was in development for 3 years, and we use conventional technology arranged in a different manner to achieve energy efficiency. Last year we won a design competition that was held by a private developer called DuPont Fabros, DFT, that resulted in $1.2 million in design fees. This data center is 60 megawatts in capacity and uses the equivalent energy of 60,000 homes. CAC will reduce the cooling cost of this client's current data center by 67% with no increase in first cost. We approached a German manufacturer of air conditioning equipment who's headquartered in Frederick, Maryland, and they agreed to build a mock-up at their factory. And Dan's going to show you a flow diagram.
So as you can see coming up, the flow diagram. And now the key to chiller-assisted cooling is to elevate the cooling fluid temperatures way beyond the industry standards. In order to do this, we needed each equipment manufacturer to create a whole new product line just for our specific design conditions. Once they had seen the business potential, they were more than happy to work with us. What elevating temperatures does for us is it allows us to use free cooling for 74% of the year. And even on the hottest day of the year, the refrigeration plant only needs to cool 2/3 of the total load. This reduces the power generation plant, which means millions of savings in capital expenditure. So we save water, we save energy, and we save upfront costs for our clients. Now here's a client or a testimonial from the Stoltz factory in Western Maryland.
Almost a year ago, architectural engineering company RTKL out of Baltimore, Maryland, approached Stoltz, who is located in Frederick, Maryland, with an idea to design a mock-up mini data center to prove the theoretical idea of a chiller-assist cooling loop. Stoltz, being an always open-minded and innovative company, was immediately interested in supporting this idea. The goal then was to put a complete functional mock-up data center together. The room here houses 3 chimney racks with a total load of 100 kW. The rack itself is ducted to a ductwork that we have put in place that goes then out to the crack unit that we have in place. On the outside, we have the other components that are necessary in order to mock up a complete data center. We have a small chiller, we have a pump package, and we have a cooling tower. So we are bringing the cold air directly into the space and then let the servers take care of the volume of air they need. It is also completely controlled to provide the right amount of air needed for the space. So we're not overpressurizing the room, we are not underpressurizing the room. We have a perfectly balanced control in place that manages the air supply into the room. What we see here is an actual Stoltz unit, one of the latest designs that we have on the chilled water, high efficiency systems. This unit here is also part of the project with DuPont Fabros in Ashburn, Virginia. There will be around about 400 of these units being installed in this entire data center. The question, of course, comes up, why so many units? And that is where we see the efficiency, how these units are deployed within the data center, and how these units will provide and supply the air into the data center. That's where we actually see the efficiency gain.
Thank you.
Thanks a lot.
Thank
Okay.
you.
Thank you, Steve and Dan.